Java programs take two forms, applets and applications. An applet is a program that appears embedded in a web document, and an application refers to larger Java programs, such as those on network servers. This module will teach you how to build Java applets and applications using the Java Development Kit. You'll learn how to download, install, and apply the JDK to the construction of both applets and applications. The objectives covered in this module are distinguish between Java applets and applications, create, compile, and run a Java application, and create, compile, and run a Java applet. Java programming is used to create applets and applications. Upon completion of this lesson, you'll be able to identify the distinguishing characteristics of Java applets and applications. Use JDK tools and libraries to create and execute Java applets and applications. Identify JDK utilities and their uses, and download and install the JDK. In Java, an applet is any Java program that is launched from a web document, that is, from an HTML file. Java applications, on the other hand, are programs that run from a command line, independent of a web browser. The size or complexity of a Java applet has no limit. In fact, Java applets are in some ways more powerful than Java applications. However, with the Internet, where communication speed is limited and download times are long, most Java applets are small by necessity. The technical differences between applets and applications stem from the context in which they run. A Java application runs in the simplest possible environment. Its only input from the outside world is a list of command line parameters. A Java applet receives a lot of information from the web browser. It needs to know when it is initialized, when and where to draw itself in the browser window, and when it is activated or deactivated. As a consequence of these two very different execution environments, applets and applications have different minimum requirements. The determination to write a program as an applet versus an application depends on the context of the program and its delivery mechanism. Because Java applets are always presented in the context of a web browser's graphical user interface, Java applications are preferred over applets when graphical displays are unnecessary. The convenience of web protocols for applet distribution makes applets the preferred program type for Internet applications. Although applications can easily be used to perform many of the same tasks. With Java, writing Internet-based software either as applets or applications is extremely easy. Non-networked systems and systems with small amounts of memory are much more likely to be written as Java applications than as Java applets. The table shown here summarizes the differences between Java applets and applications. With an application, you can provide the Java runtime environment. However, within an applet, you can only use the capabilities a browser offers. If you're using features of newer Java versions, you need to wait until browsers support the capabilities. In an intranet environment, you can expect users to still be using older browser versions, which do not support either Java 1.1 or Java 2. In a corporate intranet environment, where there tends to be more control over software versions, you can know what versions are available and develop accordingly. The Java Development Kit from Sun's Java Soft division contains the basic tools and libraries necessary for creating and executing Java applets and applications. It also contains a number of useful utilities for debugging and documenting Java source code, and for interfacing C to Java code. The Java.lang package provides classes that are fundamental. The Java.lang package provides classes that are fundamental to the design of the Java programming language, such as object handling and error processing. It is impossible to write a Java program without using this library, since it is the root of the class hierarchy. The Java.lang package provides classes that are fundamental to the design of the Java programming language, such as object handling and error processing. It is impossible to write a Java program without using this library, since it is the root of the class hierarchy. The other packages contain classes used for utilities, networking, I/O, graphical user interface tools, and web browser interaction. Packages that deal with security, database access, reusable software components, collections, drag and drop, accessibility, and reference objects are also available, and new ones are in development all the time. The core API includes some important language constructs, as well as graphics, network, and file I/O capabilities. It's generally safe to assume that the core API is common to all platforms running Java. Version 1.2 of the JDK includes utilities for developing programs, writing advanced applications, and preparing for distribution. The tools listed here are used during standard program development. The tools listed here are used during standard program development. The tools listed here are useful when writing advanced applications. Before installing JDK, the tools listed here are useful when writing advanced applications. The tools listed here are used during standard. The tools listed here are used during standard program. Version 1.2 of the JDK includes utilities for developing programs, writing advanced applications, and preparing for distribution. The tools listed here are used during standard program development. The tools listed here are used during standard program development. The tools listed here are useful when writing advanced applications. Before installing JDK, it must be downloaded. JDK 1.2 can be downloaded from Sun's Java website. The JDK is a self-extracting, compressed, executable file. Version 1.2 is available for the platform shown. Verify that you can run the JDK from any location in your computer, particularly the directory and its subdirectories where you will put your Java programs. To do this, make sure the path statement in your auto-exec.bat file includes the JDK bin and library directories. For example, if you installed the JDK in C JDK12, your path would appear as shown. For Windows NT, the path will need to be entered into Start, Settings, Control Panel, System. In the System Properties window, select the Environment tab and set the path variable. Verify that you can run the JDK. Before installing JDK, it must be downloaded. JDK 1.2 can be downloaded from Sun's Java website. The JDK is a self-extracting, compressed, executable file. Version 1.2 is available for the platform shown. Verify. For Windows NT, you can copy the Java documentation from JavaSoft to your installation directory. Unzip the documentation zip file, creating a docs subdirectory. You'll need a web browser to look at the Java documentation because it's formatted in HTML. The first step in downloading the JDK is to locate the correct binary files at Sun's Java website, or from the appropriate site if you're using a platform other than those supported by Sun. The complete JDK is distributed as a single file, and the download may take 90 minutes with a 33.6 kilobits per second modem, or about half as long with a single-channel ISDN connection, assuming that the server is not busy. Sun has a separate distribution file for the JDK documentation. This includes release notes, help files, and documentation for all of the classes and tools distributed with the JDK. It's compressed and can be accessed online on Sun's Java webpage. You can review the JDK installation instructions for Windows and Solaris platforms in the table shown here. To access the download, click the link shown.
When you're ready to create a small Java application by applying each JDK utility to the code, you'll see the code compiled, executed, disassembled, documented, and interfaced to the C language. Upon completion of this lesson, you'll be able to use a text editor to write Java source code, use the Java compiler to convert Java source code into bytecodes, use the Java interpreter to run a program and view the output, use JavaDoc to automatically generate HTML documentation for your code, and use JDB to debug Java programs. Java source code can be written with a simple text editor. In Unix, VI or Emacs will do. In Windows, you can use Notepad or Edit. Many programmers have a preferred text editor, or use the editors shipped with third-party integrated development environments. The example shown is a little Java program that you can use to experiment with the JDK. It simply prints the words JDK test drive. The name of the Java source file isn't arbitrary. It must be the same as the name of the public class defined in the Java file. Consequently, only one public class can be defined in each source file, although additional non-public classes can be defined in each file. If no public classes are defined in the Java source file, the name of the file can be anything you want. The code defines a Java class called testDrive, which contains a single method called main. When the Java interpreter tries to execute the testDrive class, it'll look for a method called main. In fact, every Java application must define a method called main as shown. The VM will execute the method shown here to run the program. Here, args is an array of string variables. When you run the program, the array will be filled with the values of any arguments it was given on the command line. You're now ready to compile your first Java program. The Java C compiler converts Java source code into Java bytecodes, which can then be executed by Java, the applet viewer, or any other Java VM, such as within Netscape Communicator. You can compile your testDrive program by entering the code shown at the shell prompt. If the Java code is acceptable to the compiler, the file testDrive class will be created. If you're curious and would like to see the details of the compilation, you can use the verbose option. The verbose option is rarely used, but seeing it at least once is instructive. The verbose option will cause the Java C compiler to tell you which other Java classes the compiler needs to create the compiled class file, and how long it took to do the compilation. When you enter this code, the results are shown. The compiler must check that the testDrive program is consistent with any other classes it uses. String, system, print stream, serializable, filter output stream, and output stream are included in Java's standard class libraries, the core API. All of these classes are essential to print a string to the standard output. In version 1.2 of the JDK, there are about 900 classes in the standard class library, the core API, and about 1,600 supplementary classes. These classes are stored in a compressed zip file in the JDK 1.2 library directory. If you want to see the source code for the library classes, access varies from platform to platform. With the Windows 95/98 NT installation, source code access is an installation time option. With Unix, it's always in the same place. If you want it installed, or it automatically is, you'll find the source code located in the source zip file in the JDK 1.2 installation directory. When the zip file is expanded, the source files are placed in the source subdirectory. After running javac to compile testdrive Java, the file testdrive class contains bytecodes that can be executed by any Java VM on any platform. The class file format is an open standard, and a detailed specification for it is available at Sun's website. For additional information on this subject, click the link shown. After compiling testdrive, you can run the program with the Java interpreter by entering the command shown. The output will be the words JDK testdrive, as shown. By adding a few comments to your Java source code, you make it possible for JavaDoc to automatically generate HTML documentation for your code. Add the comments shown to your testdrive Java file. Java uses the same kind of comments as C++, but a comment beginning with multiple asterisks has a special meaning for JavaDoc. It signifies the start of a documentation comment block, which is a comment block that will be used by JavaDoc to create documentation. Given our newly commented testdrive Java, JavaDoc will produce the files allnames.html, tree.html, packages.html, and testdrive.html, all of which can easily be viewed using a standard web browser. To run JavaDoc, simply enter this command. For additional information on this subject, click the link shown.
You're about to view a key process that uses a standard technique or procedure. Please read the introductory information before you proceed.
Load the testdrive class into JDB and set a breakpoint. When the debugger hits a breakpoint in the code, it stops executing the program and allows the user to inspect the state of the program. Tell the debugger to stop when it reaches the main method. Run the source code for testdrive. The debugger lists the code and also shows where it's about to execute a new instruction. If there are many lines of code, you could also have JDB step through the code one line at a time. Clear the breakpoint and allow JDB to finish executing the program. The output of the JDB session is shown.
In addition to creating Java applications using the JDK, You can create Java applets and the HTML documents in which to host them. Upon completion of this lesson, you'll be able to embed an applet tag in an HTML document. Write Java applet source code. Create an HTML document to host an applet. Use Applet Viewer to display HTML documents. Use Java Runtime Environment to distribute Java applications. And create, compile, and run applets. HTML files are text files with special character sequences that specify the document formatting characteristics. The special character sequences are called tags, and they consist of symbols placed between left and right angle brackets. The I-start tag sets the italic formatting, and the close I-end tag unsets it. A web browser or HTML viewer interprets the HTML file and produces the corresponding output. The HTML tag indicates that the file is an HTML document. The head tag marks the start of an invisible header section normally used for recording the title and author of the document. Some programs will only look at the header section of a document. The phrase between the title and close title tags is the name of this document. The body section of the document, marked by the body tag, contains all the displayed information. In this case, a Level 1 heading and a line of normal text. The output generated by this HTML file is shown here. The HTML tag indicates that the file is an HTML document. The head tag marks the start of an invisible. The phrase between the title and close title tags is the name of this document. The body section of the document, marked by the body tag, contains all the displayed information. In this case, a Level 1 heading and a line of normal text. The output generated by this HTML file is shown here. Adding a Java applet to an HTML document is quite straightforward. There is an applet tag that specifies the location of the class file and the display area allocated to the applet. Suppose you want to add a clock applet that will display the current time in hours, minutes, and seconds. This is a simple example of an applet tag that loads the clock applet. When a browser encounters these tags, it will start the VM and ask it to load clock.class. It also tells the VM that the applet may draw in a region that is 170 by 150 pixels. The location of the applet tag in the document determines the coordinate of the top left of the applet's display area. Add the line to load the clock applet to the HTML file. Information can be transferred from the browser into an applet. The Java programmer decides which parameters will have meaning for the applet, and the HTML author uses param tags to pass those values into the applet. When a browser encounters these tags, it will start the VM and ask it to load clock.class. Information can be transferred from the browser into an applet. The Java programmer decides which parameters will have meaning for the applet, and the HTML author uses param tags to pass those values into the applet. The clock applet needs no parameters. Telling the time is a universal function. On the other hand, the sample filled box applet needs to know what color to make the box. You can write the filled box applet to expect a parameter called color in the HTML using the param tag. The param tag accepts two arguments, name and value. The name argument is used to specify the name of the parameter, and the value argument defines its value. As far as Java is concerned, all parameters are string objects, although they can be converted to any other Java data type quite easily. If the web browser includes a Java VM, it will display the applet and ignore everything but the param tags, which lie between applet and close applet. Web browsers that are not Java enabled or have Java disabled will ignore the applet and param tags and display any valid HTML between the applet and close applet tags. A Java-enabled web browser follows a specific series of steps when it encounters an applet tag in an HTML document. The browser reserves space in the document for displaying the applet. The width and height parameters of the applet tag determine the amount of space used by the applet. The browser reads the parameters from the param tags. The VM starts and is asked to load and initialize the applet. The applet has access to the names and values in the param tags. The VM creates a running copy of the applet based on the class file. The VM calls the start method of the applet when it's ready for the applet to start processing. It also calls paint to draw the applet in the browser window. The VM creates a running copy of the applet based on the class file. The VM calls the start method of the applet when it's ready for the applet to start processing. It also calls paint to draw the applet in the browser window. The VM calls the start method of the applet when it's ready for the applet to start processing. It also calls paint to draw the applet in the browser window.